Okay, welcome back again. Welcome back. So the next concept I'm going to look at here is you've been given a vector. Once again, we will look at first, and it's in one of the species. It's one of the octans. But this time, what we're looking for is sorry about that. What you're looking for is that the they will give you they will give you the magnitude of the vector. This or the force. And they will give you some two angles. So let's see the two angles in the diagram. So either they will give you, so this is what is given. This this is what is given. They will give this angle, call it phi, and this angle theta. Or they will give you, let me take this off, or they will give you this angle, phi could be here, and then this angle. Any of them is fine. Or they could give you this angle with this angle where theta is here. Okay. So this are some information be provided. Some information we provided, or they will give this angle with that. Okay, so you have three information, and what they want you to find is to find the vector A in the ij form, ijk form, in the Cartesian form. Okay, or they can ask you to find the components of A. So components of A is find ax, ay, and az. Okay, normally if they want the magnitude of the component, then we don't want to bring in the sign, the direction it is pointing to. We just want the absolute value. Okay. So let's see how we go about this problem. Let's see how we go about this. Now, in the diagram, this line you see here, this one, is the projection of this onto the, in this case, x, y plane. That's assuming I have a touch line here. I'm looking at it. Let's say this is my eye, and I'm looking down. If I'm looking down on this and I project this onto this surface, I'm going to get this line. And that's why I've done it in dashes. I'm going to get that line in dashes. Okay? I'm going to get that line in dashes. Okay. So this is the projection. Let me call this one A kind of prime. Okay, A kind of prime. So now what I can do is that because A is vector OA is making an angle phi with the z, it means we can easily find what is the component AZ, because the angle is the z. So that side is the magnitude of A cosine phi. Done. Then if this side is the cosine, it means the other side is the sine. And that sine, that is the sine. So we got this side AZ. But the other side, if this is the cosine part, and so the other side will be the sine. The sine part is what I'm calling as A prime, which will be A phi, A magnitude of A sine phi, which is brilliant. Magnitude of A sine phi. Then how do we extract our AX, AY from this? Because if I resolve this one that way, that will give my AX. If I resolve that way, that will give my AY. And that's what we're going to do. Of course, if you want to write an IJK, you have to take the sign into account, which side is direction is pointing to. So we take A prime and resolve only A prime. And look, the angle is the x part. So the x part will be the cosine, and this will be the sine. So my AX is actually my A prime, what? Cosine theta. And my AY is actually my A prime, sine theta. But what is A prime? A prime is this. A prime is this. So sub this one here, it means you call all the components you need. You got all the components. So let me clear the screen and I'll show you that's what I exactly I've done here. So look at this. And that's what I've done here. Hence, you know your AZ, you know your AX, you know your AY. You can write them in IJK form. In this case, the AX is pointing the positive X direction. AY, this is just for illustration. Your AY is pointing the positive Y direction, and your AZ is pointing the positive Z direction. So all of them are positive, positive, positive. But some of them could be negative as well. Some of them could be negative as well. Very easy, easy concept. So let's look at an example on this. Let's look at an example on this. So in this example, let's see what is given. So have you seen it? The magnitude of the force is given as 60 newtons. The force is in a space, and if one look to, it's one on the space, it's in the negative side of y, positive side of x, and a positive side of z. So as you could see, if you really want to go from this end to that end, then you're going to walk this way, come this way, come that way, and go up. So what it means is that the x will be positive, y will be negative. So this is your ax. AY will be negative, but AZ will be positive. So if you can find these three components with that, let's see what is given. This time, compared to the illustration, this angle is given. The angle the force is making to the XY plane. The angle the force is making to the XY plane. So this line here is going to be like our F prime. And then the F prime is also given. The angle of F prime to the x-axis is given as 45. So we can easily work this out. So let me switch to the OneNote and then I'll work this example out. I'll work this example out. Okay, so let's go for it. Let's go for it. So the first obvious thing is to find what is FZ. The angle is the XY plane. So our FZ side, which is this way, yeah, which is the one FZ is here. Because this is 60. So this is going to be 30. So in fact, you can use 30. Okay, you can use 30 and say it's what? 60 cosine 30, no problem. But let's go with what we do. The angle is this side, so this will be the cosine 60. That's how it'll be sine. So you can use 60 sine 60 degrees. But let me put this down. Let me say, or somebody can also do it as 60 cosine 30. No problem. All of them are correct. Because two angles that add up to 90, their sines and cosine are the same. Okay, let me simplify a bit, because sine 60 is root 3 over 2, isn't it? So that end up will give us like 30 root 3. Let me keep the answer nicely in the exact form. Let me keep the answer nicely in the exact form. So if this was the 60 sine, then the f prime side, and this is the f prime side. Okay, the f prime side will be 60 cosine 60. And cosine 60 is half. So this will end up to be 30 newtons. Then we need to now split or resolve our f prime into two. One this way, which is our fs, and one that way, which is our fy. But the fy will be negative. So either you write the magnitude, and when you are doing, you put a negative somewhere. So your fx is the angle is to the x side. So the x side will carry the angle 45 is the x side. So the x side will carry the cosine. So you're going to get your f prime cosine. That is the magnitude of f prime. Cosine 45. Okay, cosine 45. And that will be 30 cosine 45 degrees. And 45 is root 3 over 2. So that will be 15. That's the cos 5. Cos 5 is root 2 over 2. Or 1 over root 2. So the 2 cancels 15. 15 root 2. 15 root 2. And that is newtons. The Fy, I want to, you can decide to write this as magnitude so that you don't bring that the negative sign. Then when you are doing the ij, you bring the negative sign if you want. Okay, if that's what you want, you can easily do that. You can neglect the negative out. And then when you want to write, you do that. So let's do that. Let's call fs, fy as the magnitude. So in that case, this is f prime sine 45. So that almost the same number, 30 sine 45, which is the same thing as 15 root 2 a newtons. 15 root 2 a newtons. Okay. And then, therefore, our force F in Cartesian vector form is our Fs, which was 15 root 2 I, but minus because it's in the negative side root of y, as I've said, 15 root 2 j. Then add the z. The z, as we go here, look up here, we got 30 root 3. So it's 30 root 3 k. And the answer is that. Okay. So let's see whether is that what they want. Yeah, they say we should express f in as a Cartesian vector. So it's done. They didn't ask you magnitude, they didn't ask you direction, they don't do anything. Do as the question says. Okay. So we will end this video to here, and then I'll do the last section later on. In the next, I'll do a third video now. Okay.